In this video, we're going to talk about linear programming. Example 1. You have 240 acres of land. You make $40 per hour for corn and $40 per hour for oats. Let's start highlighting some things so we can make sense of this problem. So that's going to be our part of our profit. So we'll highlight that in gray and we'll come back to that in a second. Okay, here we go. And our acres only will highlight that yellow. You have 320 hours available. Let's highlight that instead so we can make sense of this piece. That's some new information. 320 hours available. It takes 2 hours of labor per acre. And oats take 1 hour of labor per acre. So write inequalities or expressions that represent the constraint on the amount of acres of land, the constraint on the amount of hours, and the profit function. So first, let's make sense of this. We need to be clear on which variable is which. So we have, if you look on our x-axis, we see corn. If we look on our y-axis, we see oats. So for acres of land, we do know we have 240 acres of land available. We're not specifying whether we're using twice as much land for corn or oats. We're going to assume that both the oats and the corn are the same. So we're going to just say for that inequality, we'll write it as x plus y is less than or equal to 240. And we'll highlight that in yellow to match our situation with the acres. Then we have the constraint on the hours available. And we have 2 hours of labor per acre for corn. So that would be 2x plus 1 hour for the labor for oats plus y, and that would be less than or equal to 320. So let's highlight that in the green so it matches. And then we make $40 per hour for corn and $30 per hour for oats. So let's write that in silver. Set our profit equation would be P equals 40x plus 30y. We do have two more constraints which we need to take in consideration. We're dealing with a real world situation. So we do have to keep in mind that x and y both have to be greater than 0. So we'll just write that off to the side, and we'll do that in orange. So we'll just write x is greater than or equal to 0, and y is greater than or equal to 0. So now we have all of our constraints, and we have our profit inequality, our profit equation. So we have x plus y is greater than or equal to 40. So we're going to put a dot on 240 for x and the y. 240 is really close, about right there. And we're going to draw a line in between them. Let's make this line a little bit thicker. There we go. And then we have to take into consideration whether, since we're saying less than or equal to 240, we need to plug in 0, 0, since you do have that 0, 0 point available. So we're going to use 0, 0. So we have 0 plus 0 is less than or equal to 240. And 0 is less than 240, which is true. So we'll draw arrows going towards 0, 0. Now we have our situation where we have our hours constraints. So that's 2x plus y is less than or equal to 240. So on our x-axis, 320 divided by 2 would be 160. So 160 is about there. And then on the y-axis, we have 320. So that'll be 320. And then we're going to draw a line in between these 2 points. And let's make that a little bit thicker. Okay. And then we're going to plug in 0, 0. That's 2 times 0 plus 0 is less than or equal to 320. Anything times 0 is 0, so we're just saying 0 is less than 320, which is true. So we're going to draw arrows going towards 0, 0. The section you want to shade is the intersection where they would have both, there will be both the ocean color and the gold color. So I'll grab a highlighter and outline the section we need to highlight. We'll just do that in pink. So up to this point. So this trapezoid shaped area is the section that is my feasible region. So in part C, it's asking how many acres of land should we use to plan to maximize profits. So we need to find our corners. So let's find those. Let's write those down in purple. So this point here is our first one. That's the point 0, 240. Then we have this one here, which looks to be about 120, 150. Then we have this point right here, which will be 160, comma 0. And then we have the origin, which is just 0, 0. Okay, now we're going to write down our profit equation. So that's just P equals 40x plus 30y. We'll write down our points. These are the points we're going to plug into our equation to check our profit. So we use 0, 0, 160, comma 0, 120, comma 150, and then 0, comma 240. Now we're just going to finish setting it up. So we have 40 for the corn. We'll put that all the way down. Plus, then we have 30. We plug in 0. So 40 times 0 is 0, and 30 times 0 is 0, and 0 plus 0 is 0. So if we don't plant any corn or oats, we get $0, which is what we were expecting. So now we're going to plug into 0.160 and 0. So 40 times 160 is 6,400, and 30 times 0 is 0. So we get $6,400. Now we'll test the point 120, 150. So that's 40 times 120 and 30 times 150 plus 30 times 150 gives me $9,300. And then our last point will be 0 and then 240. 40 times 0 is 0. 30 times 240 will give me 7,200. So our highest is when we have 120 corn, 150 oats. So we want to make a comment to maximize profits. $120 acres of corn and 150 acres of oats should be planted. And we are done. Example 2. A furniture company makes bookshelves and desks. Each shelf requires 2 hours of carpentry work. Let's start highlighting. We'll do the carpentry work in yellow. Each shelf requires 2 hours of carpentry work and 1 hour for painting. We'll do the painting in green. Each desk requires 3 hours of carpentry work, so let's highlight our carpentry work in yellow. And 4 hours for painting. The company has a maximum of 60 hours of carpentry work and 40 hours for painting each week. So 40 hours of painting each week, and let's highlight the 60 hours of carpentry work. And this is a maximum. and they make a profit of $15 per shelf and $40 per desk. Let's highlight our profit stuff in gray. Okay, write inequalities or expressions that represent the constraint on amount of hours for carpentry. So start with the carpentry. We'll do that in ocean. So for carpentry, we have 2 hours for the bookshelves. So bookshelves are going to be X and desks are going to be Y. So we have 2X plus 3Y is less than or equal to 60. And we'll highlight that in yellow to match how we highlight it in the problem. Then we have the constraint on the amount of painting hours. We'll do that in gold. So we have, higher up in the problem, 1 hour for painting for the bookshelf, so that'll be X plus 4 hours for the desk, so 4Y is less than or equal to 40. We'll highlight that in green. This is also a real world situation, so we can't have negative desks, so we're going to have to add in the inequalities, and we'll do that in orange. X is greater than or equal to 0, and Y is greater than or equal to 0. And then we want the profit function. So they make $15 per shelf and $40 per desk. We'll do that in silver. So that's P equals 15X plus 40Y. Part B. Use the constraint inequalities you wrote in Part A to create a graph showing the feasible region of the furniture problem. So we have 2x plus 2y is less than or equal to 60. Let's plot that first. So 60 divided by 2 will be 30. 60 divided by 3 will be 20. And we'll draw a line in between these 2 points. Then we have x plus 4y is less than or equal to 40. So on the x-axis, we would have 40. And on the y-axis, 40 divided by 4 would be 10. And we'll draw a line in between these 2 points. Let's grab the line. And let's make that line a little bit thicker. Okay. Then we need to shade our graph. So first we are going to use 0, 0. So that's, so we use 0, 0. That's 2 parentheses 0 plus 3 parentheses 0 is less than or equal to 60. Anything times 0 is 0, so we're just saying 0 is less than or equal to 60, which is true, and that's that top graph. So this section right here is We'll draw towards 0, 0. Now the bottom graph, we'll just plug it again. We'll use 0, 0. So that's saying 0 plus 4 parentheses 0 is less than or equal to 40. 0, anything times 0 is 0, so we're just saying 0 is less than or equal to 40, which we know is true. So we're going to draw arrows in this section towards 0, 0. The section you want to shade is the section that has both ocean and gold. So I'll highlight it first. We'll use that pink. And now we're ready to actually solve the problem. So first thing we need to do is we need to find our points of intersection. We have 0 and 10. It looks like 25 and 5. Looks like we have 30, comma 0. And then we have the origin, which is 0, comma 0. So now we're going to use this to figure out which one gives us the highest profit. So we'll rewrite our profit equation, which is just P equals 15x plus 40y. And now just write these points out. So we have 0, 0, 30, comma 0, 25, comma 5, and then 0, comma 10. So we have 15, 15, just write down all the common things, and then plus, and then 40. And then we're going to write in our 0, 0. So for 0 for x, 0 for y. 15 times 0 is 0. 40 times 0 is 0. So we get a profit of $0, which we expect if we don't make any desk or any bookshelves. Then we have 30 and 0. 15 times 30 would be 450, and 40 times 0 is 0. So making 30 desks and no bookshelves would give us $450. Let's fix our, there we go. Then we have 25 desk bookshelves and 5 desks. So making 25 bookshelves and 5 desks. Let's see how much that costs. 15 times 25 plus 40 times 5 gives us $575. And then we have 0 bookshelves and 10 desks. So 15 times 0 is 0, and 40 times 10 should be 400. So now we can see the highest number is $575. So we need to make a statement. To maximize profits, the company should make 25 bookshelves and 5 desks. And we're done. Example 3. A local smelting company is able to provide its customers with lead, copper, and iron by melting down either of two ores, X or Y. The ores arrive at the company in railroad cars. Each railroad car of ore X contains 5 tons of lead. There's going to be 3 equations for inequality. So let's use 3 different colors for highlighters. So we have tons of lead for ore X, 1 ton of copper. Let's change that to green. 1 ton of copper and 1 ton of iron. Let's use baby blue. Each railroad car of ore Y contains 1 ton of lead. So we need to switch back to yellow. 1 ton of copper. And 2 tons of iron. The smelting company receives an order must make at least 20 tons of lead. So the key word is at least 20 tons of lead, 12 tons of copper, and 20 tons of iron. The cost to purchase and process the carload of ore X is $6,000, while the cost for ore Y is $5,000. Let's highlight that in gray, and we'll come back to that. Write inequalities or expressions that represent the constraints on the amount of lead. So let's choose 3 different colors. We'll use our ocean for our first one. So 5 tons of lead for X. So we're going to use X as for railroad X and Y for railroad Y. So that would be 5X plus Y and at least 20 tons of lead greater than or equal to 20. We'll highlight in yellow. The constraint on the amount of copper, we have 1 ton of copper in the X and Y. So let's use our gold. So that's X plus Y and at least 12, so greater than or equal to 12. And we'll highlight that in green. And then we have our iron, 1 ton of iron in X and 2 tons in Y. Let's pick a different color. Let's go with galaxy. So we have X plus 2Y is greater than or equal to 20. And we'll highlight this in blue to match how we highlight it in the first part of the problem. Then we have our cost function, which is we're making $6,000 for ore X and $5,000 for ore Y. So we'll write that in. So that will be cost equals 6,000 X plus 5,000 5,000. Okay, now we have to graph these 2 inequalities. So let's graph the first one. We have 5x plus y is greater than or equal to 20. So that was an ocean. 20 divided by 5 would be 4. So that's about there. Then 20 divided by 1 would be 20. That's about there. And we're going to draw a line in between these 2 points. From here to here, and let's straighten this line out. I'll make the line thicker. So we want to plug in, we're going to use 0, 0. That's 5 times 0 plus 0 is equal to 2. And times 0 is 0, so we're saying 0 is greater than or equal to 20, we know to be false. So we'll draw arrow 1, 0. Next one, we have x plus y is greater than 12. Plot on 12, 12. We're going to draw a between these 2 points. And we're going to use 0, 0 again. And that's just saying 0 plus 0 is greater to 0 is greater than or equal to 12, which we know is false. So we're going to draw arrows going away from 0. Our last inequality is going to be x plus 2y is greater than or equal to 20. So on the x we have 20, on the y we have 10. We're going to draw a line in between these 2 points. And we'll make that line thicker. Now let's hide all these arrows because we know this one's going to be above the line as well, because again, anything times 0 is 0. And so we will end up saying that 0 is greater than or equal to 20, which we know, so it's going to be go away from 0, 0. So start erasing some of these arrows because we do know we can tell we're going to be above the lines. Okay, we have 3 points of intersection. Sorry, points that we need to base on. The first point is this point right here, and that appears to be maybe 4 comma. Then we have 0 comma 20. We have another point right here, which appears to be, we'll take a guess at 6 comma 8. And then we have 20 comma 0. Okay, now we're ready to fill our table out. So our cost equation is 6,000. Now we're going to use our cost equation, which is a C equals 6,000 X plus 5,000 Y. And start filling it in. $5,000 and plus, sorry, 6,000 first. Since railroad X is 6,000, we have 5,000 for the Y's. And we're looking for this order pair that will minimize our costs. So our first order pair is 0, 20. And 6,000 times 0 is 0. Plus 5,000 times 20 gives me $100,000 for our costs. Our next critical point we need to look at, we have 4 comma 10. So I'll plug in 4 for 6X and 10 for Y. So 6,000 times 4 plus 5,000 times 10 will give me $74,000 in cost, lower than if we had 0 on railroad X and 20 on railroad Y. The next point we want to check out would be 6 and 8. So 6,000 times 6 plus 5,000 times 8 gives me a total of 76,000. So that's not my lowest. Then the last point we want to check out would be 20 comma 0. So 6,000 times 20 plus 5,000 times 0 will give me $120,000, which definitely does not minimize my cost. That's the highest. So to minimize costs, you should make 4 tons of ore X tons of ore Y, since that is the lowest cost at $74,000. And we are done.